So in this question, we're asked to integrate the following function, and we're given this function here, f of x is equal to 3x squared plus 2x minus 1. And so we're just going to go step by step with this. So to find the integral of this, what we're going to do is integrate it with respect to x, because it's a function of x. So we're going to be finding the integral with dx at the end. And so what that's going to look like is just this. And we know that the nice thing about polynomials is we can just integrate each term individually and then add them back together to find the overall integral. And the other thing we need to take note of is just the rules for integrations like this, which is that when we integrate any polynomial term a x to the n, so that's kind of a general sort of rule, what we do is just raise it to the next power up. So if it's squared, it's going to be cubed, and if it's cubed, it's going to be to the power of 4. And then we also divide it by that number. So it's essentially differentiation in reverse. And we're just going to work in backwards using the same rules that you're going to find on page 21 and 22 of your law tables. And so just go through each term now. What we're going to do is we're going to keep the 3 the same in front of our x squared, but our x squared is going to become x cubed because we're just adding on a power. And then we're also dividing by the number that we added on. So because it's cubed, we're dividing by 3. And then for 2x squared, we're going to leave the 2 the same. It's going to become x squared rather than just x, and it's going to be over 2. So once again, because it's x squared, and then the minus 1 is going to stay the same, but we're going to be adding an x and then dividing by 1. So we're going to see that just dividing by 1 leaves it pretty much as is. And so now we're just going to tidy this up, and we're going to see that our integral simplifies down to x cubed plus x squared minus x. So that's going to be our final answer. And one thing I almost forgot to do in this one, guys, and just spotted out at the very end, is to just add our c, so our constant of integration, because we don't actually know the limits here, and therefore, there could be a constant on the end of this, because when we differentiate a constant, it disappears, and therefore we just need to add the c at the end, and that's going to be our final answer.